So maybe zooming back out, getting at some of the questions you asked earlier, John, about, images and videos and text and all of these things, right? How do they play into these different paradigms? So I wanted to actually slice the kind of machine learning world in a couple of other ways. So I talked about this, what kinds of use cases or what kinds of data or environment do you have? And that's the supervised versus unsupervised versus reinforcement learning paradigm. But there are also different kinds of machine learning models. So for each of these paradigms, there are different models that you're using to somehow map between your data and whatever output you want. And these models can be used within supervised or unsupervised or reinforcement learning, but you basically are trying to just figure out what is the actual engine that's mapping between my inputs and outputs. And so one that often comes up, right, and I think is very present in people's minds is artificial neural networks, also known as neural networks, and then when you hear the word deep learning, it just means a machine learning paradigm that's using artificial neural networks. And they're called artificial neural networks because they're loosely inspired by the neural networks in our actual brains. I will say very loosely, and there's sort of genuine debate about how real that connection is. But if you hear neural networks or artificial neural networks or deep learning, they're roughly referring to the same thing.
At the least, it's good marketing.
Yes, it's great marketing. But also there are lots of others. So, deep learning is not the only type of model, or, neural networks are not the only type of model. There are things like support vector machines and decision trees and Bayesian models and so forth. And I'm not going to get into the details there. But what's important to know is if you want to use machine learning, you don't have to use deep learning. There are often other models you can use. And some of these are really simple to implement. There are open libraries in Python, for example, scikit-learn, where you can, in just a couple of lines of code, spin up a support vector machine or a decision tree or something like that. So some of these earlier models are more accessible than one might think. And in a lot of practical settings where your underlying data is imperfect or noisy, right? I've talked about all of these situations where you need a perfect data set to do something. But in a lot of situations where data is imperfect or noisy or something like that, we have seen often these simple models do quite well, whereas the more complicated models are maybe more brittle to these kinds of things, or otherwise just need kind of additional research before they're perfect in those real settings.
And are most of these open source right now, or are there private companies building such models as well?
Yeah, so the frameworks to create the models are largely open source. So scikit-learn, I mentioned one, but then also TensorFlow, PyTorch, and JAX are popular frameworks to be able to code up your own, your own deep learning algorithms. The models themselves, when a company creates a model and trains it for some kind of purpose, is the model itself often public? Often no. In the research world, yes. But for example, GPT, not a publicly available model. And this has all sorts of implications for who can actually build on it and who is able to audit it to really understand what's going on under the hood and what needs to be improved from a public perspective.
Right.
But you mentioned something that was important there. So most of the model work and the way you're implementing this stuff is done through Python programming language. So if someone was, say, at a technical school right now and listening to this and saying, hey, this sounds super interesting. How do I begin maybe learning Python as an entry point to be productive here? Is that right?
Absolutely. So Python, and some people are starting to prefer, Julia, another open source language, but Python is a great kind of entry point into this. And again, I think it's one of those things, like the Python language itself is open, and these frameworks on top of it are open. It really is a situation where a lot of people can just get going with these.
Okay, good. Thank you.
Yeah. And then, I guess the last, taxonomization I wanted to provide here is that, machine learning models can take in different kinds of data. So you can have supervised, unsupervised reinforcement learning. So different settings. You can have a different model in those settings that's mapping from the data to the outputs. But then what does the data itself look like? And there are a couple of kind of terms you might hear in the world that and what these terms are doing is really describing what is the data at hand. So if you hear the term computer vision, It's referring to a situation where your input or your output is images or videos. If you hear natural language processing, it means that your input or output is, text or speech or natural language of some sort. And if you hear robotics, it just basically means that you're trying to enable some kind of embodied agent to move around or do something in the real world. And so your inputs and outputs are often physical data or sensory data of some other sort.
Is there a special data case for math or for some sort of arithmetic or type of situation?
It's a great question. I haven't heard sort of a keyword for it. That doesn't mean one doesn't exist, but
Right.
There isn't, as far as I know, like mathematical processing as a particular use case.
Got it.
And I think partially this is historical, just what data sets exist have been easily, readily centered as benchmarks in the machine learning community.
Yeah, well, a company that I've worked with is doing computer vision around transmission and distribution assets, and they capture helicopter videos of these remote assets and drone videos and pictures, et cetera. And then only a tiny, tiny percentage of it is analyzed by humans because it's overwhelming. And we have clearly not done a fantastic job at upkeep and operation and maintenance of this infrastructure. And so having the ability to, as you say, 15 of these images you could probably do, but 15 billion, that would be hard. But this might be a great application set for it.
Absolutely. Yeah. And this is one where, that use case of just, predicting outages in transmission distribution infrastructure, doing vegetation management, Buzz is doing it, Priya is doing it, and there are a bunch of others. And this is, I think, just like a really incredible use case for machine learning. Yeah.